When selecting the appropriate conductor size for a circuit, the temperature rating of the circuit breaker is a critical factor. The marking rate at 60 degrees Celsius/75 degrees Celsius on the circuit breaker indicates the temperature limitations for the conductors connected to it. This means that the termination points of the breaker are only rated to safely handle conductors operating at these maximum temperatures. You must use the lower of the temperature rating of the breaker or the wire when determining the ampacity. To understand this better, let's delve into the practical application of these temperature ratings. First, determine the ampacity required for the circuit based on the load it will serve. This is dictated by the National Electrical Code, or NEC. For example, if a circuit is designed to carry 20 amps continuously, you need to choose a conductor that can safely handle at least 20 amps. Secondly, consult the NEC ampacity tables, specifically Table 310.16, which provides the allowable ampacities for various conductor types based on their insulation temperature ratings. THHN and THWN are common conductor types with insulation rated for 90 degrees Celsius in dry locations. However, this 90 degrees Celsius rating cannot always be fully utilized. Thirdly, consider the circuit breaker's temperature rating. If the breaker is marked 60 degrees Celsius/75 degrees Celsius, you must select the conductor size based on the lower of these two temperature ratings, even if the conductor itself is rated for a high temperature. Now, let's illustrate this with a scenario. Suppose you're installing a 20 amp circuit using THHN conductors, and the circuit breaker is marked 60 degrees Celsius/75 degrees Celsius. According to Table 310.16, THHN wire can handle a higher ampacity at 90 degrees Celsius. However, because the breaker is rated for 75 degrees Celsius, you must use the 75 degrees Celsius column in the table to determine the appropriate wire size. Using the 75 degrees Celsius column, you will find that a 12 American wire gauge or AUG copper conductor is typically suitable for a 20 amp circuit. If the breaker was only rated for 60 degrees Celsius, you would have to use the 60 degrees Celsius column, which requires a larger wire. Now, let's discuss the implications of ignoring the circuit breaker's temperature rating. If you were to use the 90 degrees Celsius ampacity rating of the THHN wire and select a smaller conductor, the connections at the breaker could overheat. This overheating can lead to insulation breakdown, creating a fire hazard. Therefore, adherence to the temperature limitations is crucial for safety. Another important aspect to consider is the continuous load requirement. The NEC defines a continuous load as one where the maximum current is expected to continue for 3 hours or more. For continuous loads, the overcurrent protection device, such as the circuit breaker, must be rated at 125% of the continuous load. This means that for a 20 amp continuous load, the breaker must be rated for at least 25 amps. To further clarify, let's examine how to handle different breaker temperature ratings. Firstly, if the breaker is marked 60 degrees Celsius, use the 60 degrees Celsius ampacity column in Table 310.16 to determine the correct wire size. Secondly, if the breaker is marked 75 degrees Celsius, use the 75 degrees Celsius column. Thirdly, if the breaker is marked 60 degrees Celsius/75 degrees Celsius, use the 60 degrees Celsius column, unless the equipment is marked otherwise. It's also important to note that some equipment is specifically designed and tested to accommodate 75 degrees Celsius rated conductors. In such cases, the equipment will be clearly marked to indicate this allowance. To emphasize, never assume that you can use the 90 degrees Celsius ampacity of THHN or THWN wire without verifying the temperature rating of the connected equipment. This applies not only to circuit breakers but also to other devices such as switches, receptacles, and terminal blocks. Furthermore, it's crucial to consult the specific instructions provided by the manufacturer of the circuit breaker and other electrical equipment. These instructions may contain additional requirements or limitations that must be followed. Always prioritize safety and compliance with the NEC when selecting and installing electrical conductors. Always verify all temperature ratings of the electrical components being used to ensure compatibility and code compliance. Always select the appropriate wire gauge according to the lowest temperature rating. This prevents overheating and ensures long-term reliability of electrical systems.